from time to time on the screen. So indeed, I'm going to talk about cybersecurity in automotive sector. Actually, we are going to discuss why do we even care about that. This is a slide about me. Well, I was already introduced, but what I realized recently that actually 1st of October marked my 12 years in cybersecurity. Thanks. So within these 12 years, I got a couple of master degrees, all those kind of fancy certifications, CISP, GISPs. And one of the things here, QR code, no phishing promise. Our unofficial ambassador, brand ambassador of Secure told me I need to be more active on LinkedIn. I'll promise to do that. So please connect. Thank you, Sarah. And yeah, right now I work at Secura as a team manager, and I'm responsible for cybersecurity of products, specifically focusing on industrial, automotive, and maritime. So we are going today to talk about, first of all, cybersecurity and automotive, give some background about that. Then we are going to talk about compliance. I know we all hate compliance, but unfortunately we all need it in order to boost the industry to move towards cybersecurity. Then I'm going to talk about TARA, and this is nothing crazy, it's threat and risk assessment. Jaya in the beginning mentioned something about threat modeling, how threat modeling should be done for everything. Well, it also includes automotive sector. And I'm going to give you a study case of the bus. So, why should we care about cybersecurity in automotive in the first place? Let's take a look at the, let's say, car industry from 80s. Well, actually, before 80s, everything was mechanical, so there was nothing to hack. In 80s, the first single ECU, you can call it electronic or engine control unit, started to be introduced in the cars. And the goal of that unit was actually to just control the level of fuel injected in the engine of the car. Then we are going to 2000s, then where we start to have even multiple ECUs, electronic control units. I will show you some examples later. And of course, we understand as soon as we have something electronic, digital, well, it means it can be hacked. And then we are talking about 2020, and we are talking about all the smart cities, all the connected traffic lights, and so on, vehicle-to-vehicle communications. So, of course, as soon as we increase the complexity of the systems, as soon as we spread the connected vehicles, well, we open the door for attackers. So here on the slides, why is it so complicated? This is just a normal car. This is not even maybe Tesla, something simple. I just took an example. All of those boxes are single control units. So all of those are pretty much computers, right? Some kind of control units that you can hack. We are talking about engine control unit. We are talking about electronic stability control. We're talking about heating, ventilation, and air conditioner. Body control, which are responsible for locks, windows, lights, and so on. Telematics. I can go on and go on. Everything connected to the same single CAN bus, meaning that if you can access one of them, you can probably access all of them. And to make it even a bit more complicated, here are some examples of the line of codes that you can have in the car. So we are talking about software in Boeing 787. Well, 14 million of line of code, a lot. The more lines of code you have, the more potential vulnerabilities you have. Windows 7, 40 million lines of codes. And then we take a look at the modern car, and it's more than 100 million lines of codes. Half of it is open source software. So you can imagine there are a lot of vulnerabilities there, a lot of potential for hacking. So as I mentioned already, a lot of connection in each vehicle, and actually now, basically a car is an IoT device. Because in the end, it has all the Bluetooth, wireless, 5G connectivity, and so on. So basically, it's a part of IoT. Well, we all know how many different attacks there are in IoT world. Nothing here. And let's be honest, would you even consider buying a car if it doesn't have Bluetooth, if it doesn't have smart navigation? Probably not anymore. And now we are not only talking about the personal cars, but we are also talking about trucks, buses, trailers, and so on. But unfortunately, so far, the main focus was not on cybersecurity, but on functionality. Well, because functionality sells. Cybersecurity, well, questionable. So yeah. And unfortunately, all of those smart features here, like vehicle to infrastructure, right? So the connection to the smart lights. I think Barcelona was one of the first smart cities that introduced that. Vehicle to vehicle communication, or key fob. Or third-party applications. Right now, you can open your Spotify on the car. Amazing, easy, also safe because you don't have to talk on the phone. You can actually connect it to your car. So, meaning that with all of those smart features, you open a door for your vehicle to be hacked. And I mean, there are a lot of doors because all of those boxes, those are the doors that open, they are open to attackers, and they don't need to open all of them. They can open only one, and they're inside of your vehicle. So, because we are here for the spooky Halloween, I'm going to tell you two scary stories. Well, scary story number one is not my story. I'm not going to go into details because probably people who know automotive cybersecurity know that, so I'm not going to go into details. Just for your understanding, for me, this marks the beginning of cybersecurity in automotive sector. Because at that point, two researchers, I have their names on the next slide, they prove that it's possible to hack the car and actually get the full control of the car. I recently watched the TV series called Criminal Minds. I don't know if you know that. They actually had the episode about that, how they can hack a car. Was super unrealistic, but super funny to watch because I was preparing for that talk at the moment. I'm like, yes, I'm going to mention that. So how they did it? Well, they did some manipulation of the firmware. Again, nothing crazy because it's a Linux firmware. And in the end, they gained the whole control of the vehicle functionality. What was the consequence for the manufacturer? Well, they had to recall over 1 million of vehicles from the market. So imagine the financial damage for the company. Here, and as a QR code, again, no phishing campaign. As I mentioned, I'm not going to go into details due to the time constraints. You can read about that online. There's a lot of talks. They actually presented at Black Hat about that. But in the end, the attack was executed in 5 steps. So first of all, they needed to identify the target. That was done through scanning on the, let's say, mobile network, so identify the car. Then there was some Wi-Fi connection. Well, it has WPA2, so you say, well, there's encryption. But the password was weak because they used the hard-coded passwords, which were predictable, because they were using the date of the date of the purchase of the car as part of the key. So they actually managed to crack the password quite easy. Well, then you're already within the car. Then the first unit was actually using TCP protocol. There was an open port. They performed some TCP port scanning. They connected to the infotainment system, IVE system, which is basically run in Linux. Well, if we talk about Linux, a lot of different opportunities, a lot of different vulnerabilities, nothing new there. Through there, they actually already managed to control HVAC and radio. So imagine you're driving your car, now you're on the highway, all of a sudden your music goes 100% more. Well, that's already scary. Secondly, it's dangerous because, of course, your behavior will be unpredictable in this case. Or if you can start blowing the hot air all of a sudden in your face. Again, for the safety reason, this is already scary. But this is not as scary as the next step, because after that, at this point, there is separation. So we are only talking about infotainment system, right? So we are not talking about the physical control of the car. But, well, those two researchers, amazing. They actually managed to find vulnerabilities in the firmware of another chip, which was controlling physical processes of this car. So we are talking about braking system, we are talking about steering systems. So they flashed the new firmware on this chip. Bam. They have full physical control of the car. They can spin the wheel, they can stop the car, they can do whatever you want. Well, luckily in this case, white hat researchers, right? A lot of time, a lot of resources were put into that. And luckily right now, attackers are not motivated to kill people with cars. That was part of the Criminal Minds, by the way. So maybe that's why we are still not hearing too many stories like that. But I will tell you the real story that actually happened to me and my parents. Back in 2018, I was living in Italy back then. You can see this is an actual car that was hacked. My parents came to visit me, and we decided to take a bit of a road trip, and we went to Paris. Amazing. Last day, I was moving to the Netherlands. I was on a train. My parents decided to do some last moment shopping. So they parked their BMW X5 in the paid parking lot in the middle of Paris. And then my mom calls me in 1 hour. I'm on the train. She's like, oh, somebody broke into our car. I'm like, what do you mean? like it was on a paid park, and she's like, yeah, there is no sign of any, like, you know, broken windows or anything. So somebody just managed to break into the car. So, of course, at that point, they went to the security guards, they watched some security videos, and they saw there were two guys. Well, at that point, I was not yet working in automotive cybersecurity, so I could only imagine what happened. So even now, I mean, I'm not sure, but I'm going to guess what happened. Well, the consequence in this case were they stole a lot of shit from their car. And that was, of course, also the problem of my parents. They decided to keep a lot of things in their car. But yeah, luckily the car was at least not stolen. So what happened? I can imagine that it probably was a keyless relay attack, basically a relay attack. So in this case, this is a picture that how it could have looked like. Again, I'm not 100% sure, but you always need two people. So you have attacker number 1 and attacker number 2. So basically, you know, you have this key fob, then you come to your car and it actually unlock it. So you don't need to do much. For that, you need the keyless car relay, which is basically a device that is located in your car that understands that the key fob is nearby and they communicate through some radio frequencies. So if you want to steal a car or to break into a car, you need two pieces of hardware. And in this case, one piece of hardware is placed near the car, and another one should be near the person with a key fob. Well, for the parking lot, it's funny how it's even called common scenarios parking lot, so you can Google it. There are different scenarios how attackers do it, because it's really common. So one of them, they follow the person, as a second attacker follows the person, and then basically they need to be near the key fob, but you need to be within 100 meters. Imagine you're in a parking lot in the middle of Paris. A lot of people, you will not pay attention that somebody's following you. Or, even now what they do, they install some kind of antennas in the parking machines and so on. Again, I'm not going to go into details of how this attack is possible. You can Google, but then you will think, okay, it's 2018, right? We are now in 2023. Things changed. Unfortunately, they didn't. Just by Googling, every year you will see, oh, Honda, oh, Tesla, oh, I think there was also Hyundai there. Every year, each car being stolen, and they kind of come in waves. Of course, they fix vulnerabilities, and new attack comes. Here, there's even the picture from the forum from 2021, for BMW X5 discussion. The guy was saying, oh, actually, I heard about this kind of attack, and then I saw a random guy standing near my car. Well, he kind of scared him away. But this is still happening, and this is scary. So, just to summarize a bit about that, a lot of things happening here on this website. By the way, I highly recommend to follow Upstream Security if you're interested in automotive cybersecurity. Not an ad, but they just really do a lot of research. They have a report for 2023, so they analyze all the type of attacks that are possible. And here you see that basically the top is still telematics and application service, so basically your backend, right? But of course, we are also talking about attacks on infotainment system. Again, remote keyless entry system is a second vector of attacks for attackers, and they steal cars. I mean, their goal is not to kill people, but their goal is to actually gain some financial profit. And that's relatively easy. But also from 2022, we're talking about new vectors. So we are talking about fleet control. If you're thinking about things like trucks, well, it's not a single truck anymore. You actually have a visibility to all the trucks because they're all monitored. And then we're also talking about charging infrastructure. Well, we have more and more cars. So, you know, this is it. So that all led to discussion. Okay, that's all bad. What do we do? Well, as always, the way forward is regulation. Because again, there is no financial incentive for the vehicle manufacturers to actually do cybersecurity, because you cannot really sell cybersecurity. You can sell a smart feature, but you know, if you just say, oh, but it's a secure smart feature, you have to pay 10% more. Probably as a customer, well, not you because you know cybersecurity, but a general customer, they will not be really sold. You have to pay 10% more because our car is more secure. No, you will not do that. Now, from 2019, luckily for us, car users and actually road users, there is a mandatory regulations. So those were introduced by UNEC. UNEC is a United Nations Economic Commission for Europe. which is worldwide. It includes Europe, North America, and Asia. So you can see here how many countries are involved. I think it's 56 as far as I remember. Well, basically their goal is to drive industry into more cybersecurity. And from 2022, from July actually, the regulation became mandatory. So if you are, as a vehicle manufacturer, you want to put your vehicle on the market in one of those countries, you have to have a certificate. I will explain more what the certificate means. But basically, from 2024 or 22, only for new vehicle types. And when I say vehicle type, it's a new model, right? So just any type of a model you imagine. So of course now it's still the work in progress, because it's not like every year they develop a new model. From 2022 they have to be compliant already for the new models. From 2024 for all the models. So we will see what's going to happen in 2025. I hope that I will see less and less of those kind of scary things that the car being stolen. And the idea is, of course, of this regulation as well, that you don't have to get the certificate in each country where you want to sell your car, but you do it in one country, and then there is a mutual recognition agreement. And actually, before that, UNEC was having a lot of regulations already related to safety, but only from 2019, they introduced cybersecurity. So, important things to understand why this regulation is good and why I like it, because it's not only about the end product. In this case, they actually implemented the best practice of cybersecurity, and they took the whole life cycle into consideration. So that's why the regulation has two parts. So one part is called Cybersecurity Management System. Probably most of you heard about ISO 27K. It talks about ISMS, Information Security Management System. It's a similar concept, but it's specifically focusing on engineering processes, right? On the production. It talks about testing. It talks about risk assessment. So it's not only about writing a policy and then you're done. No, actually those policies need to be implemented within the whole life cycle, starting from the design, finishing at the production line. And then the second part is vehicle type requirements. So that's where we talk for requirements for the specific vehicle model that they want to sell. And there are some other chapters in the regulation which are focused on audit, approval, and validity. And in general, the certificate for each of the models is valid 3 years. So you can be ensured that at least every 3 years they keep doing stuff. They keep pen testing their cars, they keep doing risk assessment, and so on. So far, the scope of the regulation is for transport of passengers, which has to have at least 4 wheels, so basically not a motorcycle. Then vehicle for transport of goods, so trucks, trailers, and all other categories M&O, which are basically those kind of small, electric cars. They're also in scope. And as I mentioned before, two parts. The first part is about cybersecurity management system. So we are talking about security management, we are talking about risk management, incident response, and external suppliers. And to be honest, external suppliers is really important, because the first study case that we were talking about, how they hacked into the car, well, they didn't hack into the manufacturer components. They actually hacked into third-party supplied components. And that's something that as a vehicle manufacturer, you don't have control over. So one of the important parts for each of the vehicle manufacturer is to actually get control over whatever they insert into their car. And the second part is the vehicle type requirements. So first we talked about processes. Okay, you create your risk assessment methodology. But what next? Then for each of the vehicle, you need to prove that the processes that you created before were actually implemented, right? So you show your threat and risk assessment results. You show that your security controls that you implemented on design, they're actually there. And, well, important part, and probably the most fun part for all of us, it's the testing and validation result, including penetration testing. So at this point, what is good about the regulation, the vehicle manufacturers, they cannot do this testing themselves. Or, they can, but in order to get the certificate, well, they need to go to a third party and actually do the pen testing of their systems. And in this case, they can do it through the road authorities or can do it through the technical service. They don't need to pen test all the systems, only specific one, but I'm not going to go into details. But just for your understanding, again, we are not only talking about the policies, we are actually talking about stuff that needs to be within the car. And here, as I mentioned before, important part, we are not only talking about vehicle manufacturers, but we are talking a lot about suppliers. Yes, formally suppliers are not mandated to be compliant, but due to the, let's say, their wish to work with the huge vehicle manufacturers, they have to show that they have cybersecurity in mind. They have to show that for their components, they actually thought about cybersecurity, that they did some form of risk assessment, they did some pen testing. They need to show that as the evidence in order to be able to sell their components to the vehicle manufacturers. There are some standards for that. Again, I'm not going to go into details. And another regulation, actually, that I'm not going to talk too much about, but at the moment when they decided to introduce the cybersecurity regulation, they also introduced the software updates regulation, which is not cybersecurity per se, but it has cybersecurity components, but it specifically tells you how to make your over-the-air updates secure. Let's put it this way. So now we are going to move to the part of the automotive threat and risk assessment. I'm going to give you some boring slides before I can explain the study case to set up the scene a bit. So first of all, it all kind of starts with risk assessment, because in the end, well, risk management, we saw it's a part of cybersecurity management system, and threat and risk assessment is a part of risk management. But what is risk assessment? Well, risk assessment is actually a process for identifying possible security risks to the vehicle as a whole or its systems. And when we're talking about risks, we are talking about technical threats, like, whatever attacker can do. But we're also talking about more, let's say, finance-oriented risk and so on. And actually, risk assessment is a process to analyze, rate and prioritize these threats, and also the goal is to design the security controls. So this is important. When we're talking about design of the security controls for your vehicle, it's not randomly you said, oh, I want this. No, you actually do risk assessment, you think about scenarios, and then you define your security controls. In the end, of course, you cannot treat all the risks. We all know that 100% security is not possible. So there's always should be a threshold to which you say, okay, now I'm going to accept this residual risk. An important part of threat and risk assessment that is done not only once, it's actually a continuous process, and it's done on 3 levels. It's done during the concept phase, production, and continuous improvement. And again, why do we do it? Well, first of all, in the very beginning, you need to identify what is in scope of cybersecurity. When we talk item definition, meaning any type of system that has a digital components, and that digital component can be hacked. That's an easy way to put it. Then we identify our cybersecurity goal, again, via risk assessment, and then we assign some cybersecurity requirements, do some design, and so on. Then the next part, we are doing the continuous improvement. Well, if you do TARA, you can actually identify vulnerabilities and manage those vulnerabilities. So even if you buy the third-party component and you're not sure it's secure, while you do your threat and risk assessment, you can see that there are some risk in this component, so you can still think about what type of security you can implement in your car while you do the separation, right? Then you can still use that, and in the end, as a final step, why it's used? Well, it's used as a tailored plan of approach for penetration testing. In general, there are 6 phases, well, 1 pre-phase and actually 5 phases to how to do TARA. Get used to TARA, because when you work in automotive, TARA is the way to go. The pre-phase is identify the item, and again, item as a system, a component. It can be the braking system, it can be infotainment system, navigation system. This is your item. Then we go to asset identification. Asset identification is basically the way to understand what type of parts are important of this system. Then we go to threat identification. Actually, I have slides for one of them, so I'll probably just do that. Yes. So the first, again, mentioned about the items, explained that part. Important part to keep in mind. So in order for something to be in scope, it has to have the potential impact on the vehicle functioning, basically, or any process of the vehicle's data, right? When we're talking about processing of the data, it can be even personal data, because, well, in many cases, they ask you to create an account in a car and so on. So when there is a part of the processing of data, then it should be in scope further for your threat and risk assessment as a, let's say, more detailed one. And an important part here, backend systems are also in scope. We had a customer where we had over 100 backend systems that we had to repeat this process on, because there are 100 backend systems involved in processing of the data and the controlling of the vehicle. So the vehicle itself maybe doesn't have that many, 20, but the backend, that's where it gets scarier. Then, asset identification, touched on that a bit. So basically, asset is a crucial component of your defined item. And then the idea is to analyze it from a perspective of CIA triad. We all know about confidentiality, integrity, and availability. What we normally do, we create a data flow diagram, because then we can see, I will show you an example, how we did it for the door system. And then basically an example of an asset in this case can be data, firmware, or even a communication channel. Basically, is a person who is doing data. This is up to you to define, let's say, the level of details when you go for your assets. Then we go to the interesting part of threat identification. So basically, you start to think like an attacker. Okay, what can I do to mess up with this particular asset? And in this case, again, we're talking about data, for example, of firmware. There could be multiple, in many cases, there are multiple threats linked to a single asset. Interesting that there is an annex in the regulation that has around 100 different threats that you need to consider at minimum. We never just do that. So we always do the threat modeling fully. While we use Stride, you can use, I don't know, attack trees, whatever you can imagine as a threat modeling tool. But we always, of course, check that the list of threats, actually not even that bad in the regulation, that you need to consider as a minimum when you do your threat and risk assessment. Then we go to impact, right? So, okay, there is a threat, but is it that bad? What is an impact? In most cases, you take different parameters. Safety is always important, actually number one, because the idea of automotive cybersecurity is to make sure that the road users, well, they're called road users in the regulation, basically everybody who walks on the road is secure. So, of course, you're talking about financial damage, about reputational damage. Well, you can be really use any type of methodology you can imagine, any type of risk assessment methodology. We use one in ISO 21434, which is a standard that specifically talked about engineering of the processes for the vehicles. And the last one is the likelihood. So then, again, you need to take each step and understand, okay, but is it actually realistic? Because you can take about the threat, oh, maybe an alien will come and they will steal my car. Well, it's a threat. Is it a realistic threat? Well, probably likelihood is 0.0001. So you always need to think about the likelihood. So yes, the impact is huge because they take the whole car, but about the likelihood in this case, well, then we go to the final risk rating. There we can basically see our impact, right? Again, an example. Okay, the impact of the fact that somebody stole a car is really huge, but because the likelihood is so low, then your risk in the end, well, in this case, impact would be severe and the attack feasibility very low. So your risk is 2, which is basically on the lower end, and you can just accept the fact the risk, yeah, well, maybe alien one day will come and steal my car. And as the last step of the threat and risk assessment, you need to do something with the risks. So it's not like you identified the risk and I'm like, okay, I'm done. No, you need to think about the risk treatment options. So the first one, avoid the risks. So basically, you remove the risk source. So if the risk is coming from the component, or maybe you say, my infotainment system is really vulnerable. While avoiding the risk, you take off this particular infotainment system and buy it from another supplier. That's basically avoiding the risk. Reducing the risk, well, based on mitigations. On top of that, you say, well, I'm not going to connect it to the same chip that my physical controls are connected. Not always work, but that's an idea. Sharing the risks. In this case, we're talking about insurance. Retaining, accepting the risks. Well, again, we said we cannot treat all the risks, so at some point you need to accept some of them. And ignoring the risk, well, please don't do that. And that's for the study case. I think I'm right on time. So yeah, when I started at Secure 5 years ago, actually one of the interesting things for me, because it happened at the same time that my parents' car got hacked into. I was really interested in cybersecurity at that point. And well, luckily at that point, Secure was also one of the first companies that was doing a lot of piloting with the regulation. So we worked with companies like Tesla and Audi at that point. But now we also do a lot of cool stuff. And one of the things that I did a couple of years back, is the threat and risk assessment on the door control system of a bus. So, normal bus, you have 3 different doors, and the bus driver can press the button, the door opens, he presses the button, it closes. Straightforward, the logic, some examples here. Well, door cannot be opened if the speed is higher than a certain threshold. Makes sense. So when the bus actually drives, you cannot open the door. Well, the bus will not start if the door is open. Also makes sense. So you cannot start driving if the door is not closed. And for example, HVAC will not function if the door is open. There are other conditions. Again, pretty straightforward. So when I started with that project, I'm like, come on, this is a door system. What can go wrong? Well, this is a data flow diagram of a door system. So this is all the components that you need to just control the door system opening and closing. I'm not going to go into details, but here are a lot of things that I showed before. You see here HVAC, EBS, the electronic braking system, ECM, which is an engine control model, BCM, body control model, basically responsible for all your lights, doors opening, and so on. Fleet management, and I already told you about that. This is kind of a part of the back end. Then there are also some physical switches. So on each of the doors, there are some pressure switches. So it kind of understands if the door is open or not. You cannot really hack into those because they're just mechanical, but you can break them. So that's also a type of a threat you can consider. And then, we have our 3 doors. So here we identified 6 different assets. So speed signal, the door status signal, the switches information, the pressure information in the switches actually, vehicle door status on the driver side. So the cluster part is basically where the driver sees what's going on in his bus. So it's called cluster. In the car, it's something that is like, where you see the speed and so on. Same in the bus. And then, of course, the last one is control model firmware. This is interesting because then we are talking about firmware, and in most cases we are talking about Linux-based firmware, so we are talking about potential vulnerabilities in Linux. So, as I mentioned, I first thought, come on, we will never identify any threats to a door system. We identified almost 30. Well, luckily, most of them were kind of were easy to prevent by physical measures. And well, in this case, the bus manufacturer was smart enough to already introduce those physical measures. So most of them were with a low risk. So that's where we're talking, impact is really high, because if you manage to open the door while the bus is actually driving and there are passengers inside, you can kill some people. But the thing is, in order to do that, you need to have physical access to the driver's either like kind of a cockpit, or there is like a box where you need to connect to OBD connector, then you have access to the CAN bus, but they had a physical lock there. So you need to steal a key, and it's theoretically all possible, but somebody will see you trying to break into that box. So that's why a lot of things were low. However, we did identify one high risk, so we were happy about that. At least we did bring some value. We did provide some recommendations, but no surprise here that the asset with the most, number of potential threats for the firmware. Because again, when we're talking about the firmware of any component, it's a normal firmware of any Linux operating system, maybe not always Linux, but still all the vulnerabilities that you can expect on a Linux server, you can also expect there. But the thing is, nobody really thought about securing that before because there was no need. And here I'm going to talk about one of the threats and risks that we identified as actually as high, and provided some recommendations. So if you go back to the process, we are talking about impact. When we're talking about impact, we are talking about damage scenario, right? So what is, there is a threat, but what is an actual damage? In this case, the damage should be considered from a perspective of the road user, because that's how regulation wants it. So in this case, we say, an attacker can tamper with limits inserted in the firmware, right? So we discussed that basically you cannot open the door if there's a specific, if the speed is higher than 10 kilometers. So if you can modify this limit, then you can press a button, actually while the bus is 100 kilometers driving, and then the door is open. And then we identify that as a damage scenario, and then of course it means unsafe conditions, because you never know what happens after that. We identify threat actors as an engineer, so basically he just didn't consider when he was coding some software on top of this firmware, that he didn't consider, all the best practices in software development. He introduced some bugs unintentionally, and then, an attacker can actually exploit those, or a malicious actor. Well, with malicious actor, again, we identified it's pretty much difficult. I will explain later why. But with engineer and intentional, it's still realistic. So what we say as a potential risks that they actually need to think about was related to policies and processes. So we said, okay, potentially a developer can introduce the vulnerabilities by mistake in coding of software, of body control model and cluster, which will prevent the door system from functioning as intended. Why specifically BCM and cluster? Well, because those were specifically developed in the house, in the vehicle manufacturer, so they were not buying it off the shelf, but they were actually developing it in themselves. Well, we identified the risk as high, and then we say, well, you need to mitigate that. The mitigations are straightforward. Educate your engineers, make sure that they follow up all the software and hardware development best practices, and so on. And then, that I mentioned already. And there was another example of the threat that we saw. This one was low, but just to explain to you how it all can work. So an attacker can perform malicious changes to the firmware, again, of BCM, ECM, HVAC, EBS, which will prevent the door system from functioning as intended. And then if we take a look at the steps of this attack, you need to get a physical access to the vehicle. Well, then the vehicle manufacturer told us, it's pretty much not possible because the driver door has a security design window. An attacker cannot really easily reach it, and then the driver's door is lockable. We say, okay, then it's pretty much the likelihood of that is really low. Then you need to connect the malicious OBD device. So basically, OBD is the port that is used to, if you need to maintain your vehicle, you need to connect with the OBD device to the OBD port, and then you can access everything that is connected to the same CAN bus. And then we say, if you have the malicious OBD device, you connect it there, and then you introduce the malware. They told us, actually those devices are not that easy to reach. They belong to us as a manufacturer. They're in some lockable places, and so on. Again, we say, in this case, low likelihood. Then you introduce the malware to the door system. They say, no, we actually do verify some integrity of the software and firmware that we develop. Again, we say, that it's low. And then, of course, the last step, the malware makes malicious changes. The conclusion here, this threat was, yes, with a high impact, because if you can actually manage to do that, then you can control the door system and open it and mess up with some thresholds. But because of the likelihood at which so low, the threat itself was low. And this is my last slide. So just some conclusions. When we normally think about compliance, we think about ticking some boxes. It's not only about that, because in the end, this is the only way to kind of force companies to start thinking about cybersecurity. It's also really important because of the control over suppliers. And again, we said, suppliers are not mandated to be compliant, but if they want to work with the vehicle manufacturers, they have to. Threat and risk assessment is really important, because if we didn't do that, we would miss some threats, right? As I said in the beginning, I thought, the door system, what can go wrong? I wouldn't even put it in scope of cybersecurity. I was wrong. And then actually threat and risk assessment is mandated by regulation. So again, this is important. And also some of the threats can actually affect the safety. So, we're not only talking about financial damage anymore, we're talking about safety, we're talking about lives. And compliance is not just bureaucratic, it's actually the only way to move the world, and not only automotive, we're talking about industrial, we're also talking about maritime, because if you think about the ship, there's not that much cybersecurity, trust me, we also work there. But if you introduce the regulation, you will force and you will drive the market into cybersecurity. And this is my last slide. Actually, this is my last slide. The previous one was not last. If you're interested in our talk and do some cool stuff, this is Sarah. Again, Not Phishing campaign. You can find her. You can see what type of career you can get with us. And this is it. Thank you.
Thank you so much. So I think there are a lot of people with a lease car. So I'm very interested if I should change mine. So what kind of brand is has the highest risk? Can you say that? Do you know?
No, I cannot say that based on my experience. But if you start Googling, they all have vulnerabilities, especially the key fob part. There was some testing done 2 years ago. 90% of the tested cars were acceptable for this attack. So actually, finding mitigation that I didn't mention, you can use a Faraday cage for your key fob.
Oh, that's a great. I want to pack my whole car in foil, but
you can actually buy that. Now they sell the Faraday bags for the key fobs.
Oh, that is so good. Thank you for this tip. So, are there any questions in the room? We have some time before lunch. I see a question. Where is my lovely colleague in the back there?
So you mentioned this interaction between manufacturers and then you as or your team as analysts of that system. That seems like a bit of a how shall we say adversarial kind of setting. To what extent have you seen vehicle manufacturers actually integrating like threat modeling, TARA, whatever you name it, into the development process themselves? Like not getting someone in from the outside?
Yeah, of course. Yeah. I mean, in the end, they're not mandated to use the third parties. So we did see some manufacturers. Actually, what we normally do, we do it once with them as like, let's say, a training exercise, and then the vehicle manufacturers can do it themselves.
So you guys repeatedly brought up validation. Right, verification is, did we build this correctly to the requirements, to what we said we were going to do? Can you talk about how you consider validation to be done on a system of systems for an entire car, for example, for what those activities look like?
Yeah, that's a really good question and a really tricky one. We have never done the full, let's say, pen testing, in this case, let's say validation on the car level, because it's really complicated. So normally what we recommend and what we do it on the item level, let's say system by system. And then after that, we do the TARA on the whole, let's say vehicle, and we identify some scenarios which are kind of plausible in this case. And then we only test those plausible scenarios, because otherwise you will be stuck testing for ages and that you might not get that much value. So we test on the item level, do TARA on the whole vehicle, and then create some plan of approach, and then we test only, let's say, high potential risks. Does it answer your question?
Sure.
I don't have a better solution, unfortunately.
So yeah, you mentioned during the TARA process the whole CIA triad, but yeah, I think a lot of us might be familiar with another concept coming into that triad is the authenticity, basically. So a lot of regulations are explicitly mentioning that. I'm not sure if the car industry is catching up to that, but how do you expect the addition of authenticity of data will impact all these assessments and maybe in general the car industry?
Well, basically already a part of, let's say, authenticity, you can also argue it's a part of integrity, because in the end you do some firmware checks, checksums and so on. And that's where they talk about software updates specifically as a separate regulation. And that's where they talk about authenticity and how do you ensure that you don't mess up during the process of software updates. And they specifically focus on the over-the-air updates, but not only.
I was wondering, what are some of the biggest risks that you see across the landscape? Like, are we gonna face car manufacturing going out of business because millions of cars got hacked and derailed, or what are we gonna see, or what are the biggest risks?
To be honest, I can agree what was I showed before. The backend systems are always the highest risks because that's where, let's say, the attackers are comfortable with hacking because it's a normal, let's say, backend system. And that's the more we introduce the backend systems, the more we open the doors to the car. So that's where I see the biggest risks. Luckily, again, during to the regulation, they have to take that into consideration as well. So they have to test their backend as well.
I heard you mention that a lot of the systems are already open source. That has the advantage of the systems being, I guess, easier to audit. Is there also a car company that you know of, or is maybe some process that wants to fully use open source back-end or front-end systems?
I haven't heard about the ones that fully use open source, but I think statistically they do use some open source. I had this discussion last year at one conference, at one of the talks, and basically there are companies that offer solution to test your code, if it's your code on open source code, but of course they do it on the code level, so meaning that they have to provide you the code if it's open source, it's good. So with open source it might be even better because then you can actually test it, run some code analysis and so on. I think the bigger problem is actually the code that they develop themselves. Or if they buy some proprietary software from a large companies, because then they don't have control over it. And that's where I see the bigger risk, maybe in this case, than the open source.
Second, not really related question. When you as Secure get hired to do this work, how big a team do you approach such a project with, and how much time do you spend on it?
So normally when we do projects, we at least have 2 people. So we have like a 4-eye approach. So when we do this kind of threat and risk assessment, it's always at least 2, sometimes 3 people. And when we talk about the man days for each system, we take between 15 and 20 man days spread within the periods of time to do this kind of threat and risk assessment. Because we do it in the workshops. So the thing is, like, you need to communicate with the customer a lot because I am not an automotive engineer. So a lot of things they really have to explain to me how it works. So I'm like, why do you need this physical switch? And then they need to really explain to you a lot of information so I can understand how I can hack it, right?
Hey, you mentioned during the presentation that most of the problems you see in the cars or the automobiles, like, is from the third-party components, but not the components that were made by the company itself. So, are there like any regulations or standards that those third-party components need to satisfy before they can be integrated in there, or they are not being tested at all, and like anything can be added there?
Yeah, so basically, as I mentioned, for suppliers, there is no mandated regulation yet, but there are a lot of things coming, like NIS2, I heard it was discussed before, that will also force a bit more suppliers to do that. But right now, as a vehicle manufacturer, they should be in control of the risk coming from suppliers. So by working with big manufacturers, we know that they have a list of requirements that they pass towards their suppliers, and they say, well, if you want to sell to me, please be compliant. And those requirements are literally the same that the requirements for vehicle manufacturers themselves.
Okay, just out of curiosity, like what kind of components are these that are like third-party components that are not being manufactured by the car manufacturers themselves?
Example, all the infotainment systems, all the navigation, it's never done by the vehicle itself. But actually, in most cases, vehicle is just like, they took different puzzles, they put it together. They rarely manufacture these kind of systems themselves because historically, the vehicle manufacturers, they used to do mechanical stuff. They're not used to do like infotainment, navigation, and so on. So that's why they have to purchase it from big suppliers. So pretty much everything digital comes from the suppliers.
And how does that work for like the smart cars that can just auto drive?
Yeah, well, we're talking example of a Tesla. Of course, they do most of the stunts themselves. But because Tesla is not that much of a vehicle anymore, it's basically a driving computer. But historically, Tesla was developed like that. They were not developed as a car manufacturers, right? So we're not talking about Volvo, which is historically a long time on the market as a mechanical device. Tesla is a smart device by per se. So of course, in this case, they develop everything in-house.
So does that increase the threat model, or like how the threat actors attack it, or?
I mean, you saw some news there. Everybody can be attacked. So I would not say it increases or decreases. It's just different.
Okay. I mean, I thought like because more devices are not fully mechanical and can be controlled via maybe IoT devices, then it would basically increase the threat landscape on which the attackers can attack, right?
Yeah, of course. The more digital stuff and the more smart features you have, the more threats you can imagine.
Yeah,
yes.
exactly.
But if you develop in-house, it means that from the very beginning, I hope that you think about cybersecurity, unlike when you buy from somebody, because then you don't have the cybersecurity mindset.
Yeah, fair enough. Got it. Thanks.
Okay. Thank you so much for your great questions. Anna will be at the Secura booth. I think it's on the long side. And this is your extra goodie bag for being a speaker. Let's give a hand of applause for Anna.
Thanks.